Hi guys, in this video I'm going to be going over the Unit 4 review document. So let's go ahead and start with number 1. Number 1 is not in slope-intercept form. So that's the first thing I need to do is move a few things around to get it in slope-intercept form. So I'm first going to move my x over to the right-hand side. So now I have 2y equals positive x plus 6. And then I need to get y alone, so I need to divide by 2. So on the right-hand side, I'm going to divide each individual piece by 2. When I do that, I get y equals 1/2 x plus 3. Okay, I'm going to begin with my b, which is 3. So I'm going to put my y-intercept on my y-axis, and then I'm going to move with my slope, which is m. And so I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. And we only require 3 points on your graph. However, the more points, the easier it is for you to draw a line. So I always put extra because then it makes drawing the line a little easier. When you go in the other direction, so when you go to the left, you have to go down 1 over to the left 2. You have to do the opposite. Okay, so now we are ready to draw our line. And don't forget your arrows at the end. With number 2, we need to graph x equals -3 on our graph. It's important for you to remember the acronyms HOI and VUX. If it starts with an X, then we know that we are using VUX, and it is going to be a vertical line at whatever number you're using. So it's going to be an undefined slope. That's what that U stands for. So we are going to draw a vertical line at -3. Hopefully yours is straighter than mine. And then put arrows at the end. If it asked for your slope, then you would say undefined. Okay, so now we are at the bottom of the first page, number 3. A line goes through points 2, 1, and 4, 6. What are the equations in point slope form? There are 2. So point slope form is y minus y1 equals m parentheses x minus x1. So the first thing we need to do is we need to find the slope. So we're going to do that by finding the difference in y over the difference in x. And so we have 6 minus 1 over 4 minus 2. 6 minus 1 is 5. 4 minus 2 is 2. So our slope, our m, is 5 over 2. And now we're going to write the 2 versions of point slope form because we're given 2 different points. So I'm going to use the first coordinates in the slope to write the first one, and then I will show you the second one. This one is asking for both of them, so in order to get this right, we need to have both. So y minus y1, which is 1, and then our m is 5 over 2, and then our x is 2. And then in green, I'm going to be using the other coordinates. So y minus 6 over equals 5 over 2, and x minus 4. So you would need both of those in order to get this question right. Okay, so now we are on the second page. And for number 4, we need to use our acronym HOI, H-O-Y. So since this starts with a Y, we know that this is going to be a horizontal line at the number. So for example, a horizontal line at +4. So I can go ahead and draw that and put my arrows at the end. And if I my O in hoy is actually a 0, so I have a 0 slope. Okay, so now we are at number 5 on the second page, and it says a vertical line goes through point 3, 4. 3 is our x, and 4 is our y. What is the equation of the line? So we know that when we have a vertical line, we're using our acronym VUX, vertical line, undefined slope, and then also all of our x values are the same. So for example, all of our x values would be 3. So we could have like 3, 5, 3, 7, 3, negative 10. Okay, all of our x's are going to be 3. So this equation would be x equals 3. That's what it would be. And if you want, you can like graph it off to the side to see, to double check and see what it would look like. So if you put a few tick marks, I'm going to put a green line, green vertical line up and down at 3. And then we could also see this point 3, 4. So you go over 3 and up 4, it's on that line. Okay, so number 6 on the second page, we are graphing the inequality below. It is already in slope-intercept form, so we don't need to do any moving around with the equation. We are first going to like put some points on the graph just like we would if it was an equal sign. So our y-intercept is 3, so I'm going to put a point on the y-axis at 3. And then my slope is negative 2. So that means that I need to go down 2 over 1, down 2 over 1, down 2 over 1. And I'm happy with that amount of points. Okay, guys, so now we need to figure out if we have a dashed line or a solid line. So kind of like with open and closed circles on number lines, if we are going to have a solid circle or a closed circle, if there's like the little half of an equal sign underneath the greater than or less than symbol. So in this case, we are going to have a solid line. And so that means anything that falls on the line is a part of the solution. And then it says y is less than. So we need to shade underneath. And before you shade, you can double check and make sure that you're right by testing a point. So the easiest one to test is 0, 0. So if you plug in 0 for y and 0 for x, and if the statement is true, then that means that you're shading in the right area. So 0 for y. So then we have 0. The statement is 0 is less than or equal to 3, which is a true statement. So that is right. We need to shade below. We need to shade in this area right here. So that's it. That's all we need to do. Okay, so now we are on the third page and we need to graph this inequality. It is currently in standard form, and the easiest way to graph something is when it's in slope-intercept form. So we need to move a few things around in order to get it in slope-intercept form. So then we have negative y is less than negative 2x plus 6. And then we want y, not negative y, so we need to divide or multiply the whole thing by negative 1. Since I'm dividing by a negative, and if you're multiplying, that's fine. But multiplying or dividing by a negative means that we need to flip the inequality symbol. So don't forget that part, because that totally changes your graph. And so now, whoops, don't forget to change that plus 6 to a negative 6. Okay, so now we can graph. So our y-intercept is -6. So let's put a line, let's put a point at -6 on the y-axis. And then our slope is 2. So we need to, it's a +2, so we need to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, now we need to figure out if our line is going to be solid or if it's going to be dashed. So since it does not have the little like equal sign under it, it's going to be dashed. And basically what that means is, and why that's like important, is it means anything that falls on this line is not a part of the solution. So kind of like when we have an open circle on a number line, that number is not included. Okay, now we need to figure out where we need a shade. I am assuming, since it says y is greater than, that we need a shade like above, so to the left-ish of the line. However, we can always test a point just to be sure, so you don't have to, if life was normal, if we were in school and you were shading and then had to erase it and shade the other side, that would be annoying. So let's test this point, 0, 0. So 0 is greater than 2 parentheses 0 minus 6, and so this says 0 is greater than -6, which is a true statement. So yes, that is the area in which we need to shade. Okay, now we are on question number 8 on page 3, and it says, is 1, -4 a solution to the inequality? So all we have to do is just plug in the x and plug in the y into the inequality, and if it's a true statement, then it works. It's a solution. Okay, so we are going to plug in the 1, and we're going to leave the negative symbol. So -1 minus 3 times -4 is greater than 12. So first we need to do the -3 times the -4, which gives us a +12. So we have -1 plus 12 is greater than 12. So -1 plus 12 would give us +11. And so this says +11 is greater than 12. That is not true. So this is not a solution. Another way that you could do this is you could put the equation in slope-intercept form, and you could graph this on a graph and then see where you shade, and you would realize that you wouldn't be shading in the region where this point is. Okay, so for number 9, we have an inequality word problem. So we need to do some translating. Tucker is purchasing buffalo wings and hot dogs for a Super Bowl party at his house, and he wants to spend under $78. So that means that on this side over here, whatever is over there needs to be less than $78. So it says a package of hot dogs costs $2 while a package of buffalo wings costs $5. Select the inequality in standard form that describes the situation. Use the given numbers and the following variables. So X is going to represent the packages of hot dogs. So we know hot dogs are $2, a package is $2. We don't know how many they're buying. So we're going to put an X with the 2. And then the hot dogs plus the buffalo wings needs to be under $78. So the buffalo wings, the buffalo wings are $5 each, and we're using Y. So this is the correct way to set up this inequality, and now we just need to see which one matches it, which it looks like C is the correct answer. It matches our inequality. Alright guys, so now we are on the 4th page and we are at question number 10. This question is dealing with transformations of linear functions, and we haven't spent a ton of time in class talking about transformations, but you all know how to do this. This is kind of like common sense. So I'm going to walk you through it. So the line given by the equation y equals x, so this is like the original equation that we're working with. Sometimes this is called the parent function if it's a function. And so y equals x, that means that your points are going to be like 1, 1, 2, 2, 3, 3, 4, 4, etc. So hold on one second. Okay. So if you were to graph this, and I'm going to do this in blue, it would look like this. So you'd have a point at the origin, you'd have a point at 1, 1, 2, 2, 3, 3, 4, 4, and you could go the other way as well. Okay, so it would look kind of like this. This is saying that it's shifted down 3 units, so that's going to impact our y-intercept because it's shifting down 3 units. And it's also going to impact the whole equation, but specifically when we're talking the whole function, but when we're talking about the equation, it's going to impact the y-intercept, and then it's also stretched vertically by a factor of 3. Okay, so in red, I'm going to shift this down 3 units. 1, 2, 3. Okay, so here is my first point. My first point is now at -3. And then it says it is stretched vertically by a factor of 3. So my original one had a slope of 1 because it was up 1 over 1. My points were at 1, 1, 2, 2, 3, 3, 4, 4. If this is stretched vertically, then it's going to be like steeper, okay? So that means that we need to have a steeper slope. And if it's by a factor of 3, then that means it needs to be steeper by 3. So this time we are going to use a slope of 3. So we're going to go up from our y-intercept 1, 2, 3 and over 1, up 1, 2, 3, over 1. Okay, and so this red line would be the line that is shifted down 3 units and stretched vertically by a factor of 3. So we need to write the equation of this. So we would obviously use slope-intercept form. We know that now, since we shifted down, that our y-intercept is at -3. And since we were stretched vertically by a factor of 3, then our slope is 3, and we need to write our x. So this would be the equation for this line. Okay, so for this next question, you could do a few things. You could type both of these equations into your Desmos graphing calculator and have the graph them and look at how they've transformed. I'm old school, so what I'm going to do is I'm going to draw for you both of these lines. So again, guys, when we have like y equals x, it's just going to be like a perfect diagonal line. So it would look like this because you have points at 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, etc. Okay. The second one I'm going to do in green, and my y-intercept is at +3. Okay. So obviously I have gone up 3 units. So I'm looking for the ones that say up 3 units. So A and C obviously don't work because they say down. And then my new slope is
up 2 over 1 because it's positive 2. So I would have to go up 2 over 1, up 2 over 1. If I was going in the other way, I would go down 2 over 1, down 2 over 1. Okay, so just by looking at this line, and I know this line is not perfect whatsoever, we can tell that our line is steeper. Okay, so since it becomes steeper, B would be the right answer. A situation in which something would become less steep, so if this was your original graph, and then if your slope is a fraction, so our original graph, our slope is 1. If your slope for your new one is a fraction, that means it's obviously smaller. So then it would be less steep than the original. If the coefficient in front of the x is a bigger number, then it becomes more steep. All right, number 12 is talking about perpendicular lines. So line P passes through points 8, 9, and 3, 7. Line Q is perpendicular. We know that if something is perpendicular, that its slope is the negative inverse. What is the slope? So first, what we need to do is find the slope of P, and then take the negative inverse of that, and that will be the slope of Q, which is what we're looking for. So I find slope by doing the change in y over the change in x. The change in y, so 7 minus 9 over 3 minus 8. 7 minus 9 is negative 2. 3 minus 8 is going to give me negative 5. I have a negative over negative, so it's going to be a positive answer. So this is my slope of line P. However, this is asking for the slope of line Q, which is perpendicular. So I need to take the negative inverse of this. So I need to flip the fraction, put 5 over 2, and then add a negative, and that is my slope of that perpendicular line. For this next one, it's asking the equation of a line Q. The equation of the line Q is y equals negative 6x minus 6. Line R is parallel to line Q and passes through this point. What is the equation of line R? So what we need to do is we need to think about parallel. If something is parallel to one another, what is the slope like? The slope is the same. So for line R, our slope is going to be negative 6. Now we're going to use this point to find our y-intercept of line R, because we don't know our y-intercept, because parallel lines do not have the same y-intercept. So we need to use these points to figure out our B. So we're going to plug our information into our formula, our slope-intercept formula. So our y is 4, our m is negative 6, our x is 1, and we are looking for our B. Okay. So our B is positive 10. So now we just plug in our m and our b into the equation, and then we have our equation. So y equals negative 6x plus 10 is our slope-intercept equation for that line. Okay, so if you have not already done this, what you need to do is you need to go to your Desmos graphing calculator, and you need to press the plus sign and press table and insert your x values under the x1, and then insert your y values under y1. When you do that, you should have points that pop up on your graph. So it's like a scatter plot because there's points everywhere. So you need to leave those points there, and then we are going to find the line of regression. This question is Desmos dependent. We need Desmos in order to do it. So you need to be following those steps. If you haven't done that, do that right now. Pause the video and do that right now. Okay, then guys, when you are in Desmos, you don't want to delete your first section that has the table, you want to add a new plus sign. And I wrote these steps right here. You need to do these steps, guys. Desmos, you're going to have that on the SOL. You're going to have it on your tests. So you need to take advantage of this resource. So you're going to press the plus sign. You're going to press that you're going to add an expression. And then you're going to write this. So you're going to write y1 because that stands for a point. You're going to use this little symbol that looks like a squiggly. It's called a tilde. It's in your keypad in Desmos. You just have to find it. So I think it's with in the bottom right when you have like the little numbers. Press that part of your keyboard and then the tilde should show up. And then you need to do mx1 plus b. When you type that in, it is going to give you your line of regression. Okay, so again, you should have typed that table into Desmos and then you put this formula into a second row in Desmos. When you do that, you see your M and you see your B. So you can write your linear regression, your line of regression, because you have your M and your B. You need to round to the hundredths place, which is the second number after the decimal. So for our M in Desmos, you see 1.02 and there's a 3 afterwards, so I'm just going to leave it at 1.02. And then our B is 0.933, so I'm just going to leave it at 0.93. Okay, and now we just need to write it in y equals mx plus b format. So y equals 1.02x plus 0.93. I'm going to be completely honest with y'all. I did not have Desmos when I was taking algebra, so you should be very thankful for this resource. Also, it'll do all the work for you, so make sure you use it and make sure you know the steps. Okay.
Okay, so now we're on the last page, yay. So this one is going to be the same process as what we did earlier. So you're gonna need to use the Desmos calculator. So the first thing that you need to do is you need to type your table into Desmos. And how you do that is going to the Desmos graphing calculator, pressing the plus button where it says add item and pressing table. Then you need to type in your x values, which are the top ones, and then your y values. Okay, so let's go ahead and do that. So I am typing my x values in, and now I'm typing my y values in. The reason why we do this, guys, is because the slope is not the same. Like, this is real data where the slope is not going to be the same every single year, for example, with this one. So we're just trying to find a line of best fit, like what would be the approximate slope using these numbers. Like, what could we guess is going to happen for the 5th year? Okay. All right. So I put these numbers in my table, and then on my graph, they should show up. You may need to zoom out in Desmos so that you can see your green points. If you type in the table, they will pop up automatically. You just might need to zoom in or out to be able to see it. So then you need to press the plus button, and we are going to be adding a expression because we need to figure out our line of regression or our regression equation, same thing. So in your Desmos calculator for your second row, you need to type in this formula, and this is going to give you like an approximation, I guess I should say. So you need to type in y1 and then this little squiggly, which is called a tilde, and then mx, and you need to put a 1 with that, plus b. So I'm going to type that in right now. When you do that, it's going to give you an m and a b at the bottom, and you need to round to the nearest hundredths place, which is the number after, 2 numbers after the decimal. So my M is 2.95 and my B is 30.84. Okay, so now all I have to do is just plug these into my equation. So this is like how we can assume and use the formula to assume what the next point is. Again, this is these are scatter points, so it may not be exact. That's why we use the tilde and not like an equal sign. So y equals M is 2.95. You to write the x, and then B is 30.84. Okay, and then our last part is asking estimate the amount spent on toys and sport supplies in 2012. Okay, so the first year is 1990. So if I was to go from 1990 to 2012, that is 20 years. You could just put that in your calculator, and you'd realize that is 20 years. So, I'm sorry, it's 22 years. It's 22 years. And so what you need to do is you need to plug in for X 22, and this is like an estimate amount of what is spent on toys and sports. So we need to make sure we're plugging in 22, not 20. Sorry, guys. So we have our formula. I'm going to write it down here. Y equals 2.95 x plus 30.84. Okay, now plug in that 22. Make sure you plug in 22, not 20, because I misspoke earlier. Sorry about that. And see what the estimate is. So obviously you're going to multiply first. So when you put in your calculator, hold on while I pull mine up. When you put 2.95 times 22, you should have gotten 64.9, and then we need to add 30.84, so plus 30.84, and when we do that, we get y equals 95.74. This is an estimation. Okay, so this is the estimate amount. It may fall a little above, it may fall a little below, but that's the estimated amount spent in 2012. All right, props to you for doing this review and watching the video and checking your work. Reach out to your teacher if you have any questions, and good luck on the test.